today I'm going to talk about animating SVGs, and the main bulk of it is about SVGs. And I'll show you how to animate with different methods possible. Before I begin, can I have a show of hands? How many people use SVGs already? Cool, nice. All right, how many people know how to animate SVGs with CSS? Nice. SMIL? Oh, not a lot. Okay, great. And JavaScript. Okay, cool. So, good. So, I'm Zell. And I'm not going to talk a lot about myself because I have a lot to cover. So just two quick things. I wrote 2 books. One is Learning Susy, which teaches you how to use the Susy framework, and the other is Automating Your Workflow. And you can find me at my website, zell-wechat.com, or my Twitter handle at zellwk. I have no idea why I put that URL as I don't know what I'm thinking when I created a website. But anyway, so the slides are going to be up on this link if you want it, so grab it later. So today we're going to go through the basic SVG stuff, a very, very quick one, then some animation methods to see how we can animate SVGs. Then we are going to go into a more complex one, and then we're going to see some cool real-world effects. Very quickly, let's go into the basics. So why SVGs? I believe in using SVGs because it has good browser support. Basically, any browser supports SVGs right now. It's stylable, it's highly stylable, you can do a lot of things with it. And the best of all is scalable, meaning you can build your animations for the mobile or for the desktop and beyond. It's up to you. Going to the basics, there are multiple ways of using SVGs. For example, using it as an image tag or a CSS background image like this, or an object tag, which I don't see many people using it, and inline SVG, and, well, multiple methods. We're not going to cover so much on the basics in this talk right now, so we're going to just use inline SVGs because it's the one that supports everything, just to make our lives easier. So, animation methods. There are basically 3: CSS, SMIL, which stands for Synchronized Multimedia Integration Language, and JavaScript. Browser support for these 3 animations are pretty good. CSS is IE 9+, so as long as you can use CSS transitions and animations, you're fine. SMIL, if you're going to support IE or Opera Mini, you can't use it. And JavaScript has the best support so far. It goes way back to even IE 6 if you use some good libraries. For the first part of this talk, we're going to talk about translation, meaning like moving the SVGs from left to right, and rotation. You'll see why rotation in a while because it's a little bit complex. First of all, here's the SVG we are going to use. This is the square that we have. So if I run this, you'll see a square, hopefully. Yeah, a square. OK, animating with CSS, first of all. You want to use CSS when your animations are simple. You don't have a lot of different weird timing functions. You don't have to think too much about delays and stuff like that. And you want to animate properties that only CSS can animate, which is most of them except for the path data thing, things like that. When targeting SVGs in CSS, you can either target the SVG element. That works very, very much like the same as HTML div elements, so we are not going to go into that. The other one is to target the elements within the SVG itself. That's slightly more complex when it comes to animations because things start to change a bit. So first of all, translation. I believe many people here already know how to use transitions, so we're not going to cover that. But transitions, if you do a transform, you're basically moving it to the left by 100 pixels. You can also use animations. Like the important thing to note is the keyframes over here. If you know the keyframe syntax, you can basically do animations just like transitions with SVGs. Nothing to worry about. So the left and right thing is pretty simple. However, when it comes to rotation, it's not as straightforward as it. So right here, I've written rotate 360 degrees. So let's take a look at how this SVG runs. It's kind of weird because it goes out of the box and then it comes back again. If you notice, it hovers over at this edge over here. So this is the origin point of the SVG transition. Well, if we want to translate at the center, we have to set the transform origin to 50-50%, and hey, it works. However, the problem is that this doesn't work in Firefox. If you want this to work in Firefox, you have to set the transform origin to pixels or any other unit that Firefox uses. So if you're going to do rotation with SVG animations, it's best not to use CSS if you want to support Firefox. And let's go on to SMIL. We'll be going to do the same thing. You want to use SMIL, likewise, when you use simple animations. You need slightly more control compared to CSS. You'll see why later. And you don't have to support IE or Opera Mini. The Simul animations, you can use the animate tag. Basically, Simul animations, you're going to write it in the SVG itself. It's kind of like writing HTML and inline styles at the same time. So you can either put it within the element, like this is the rectangle we have earlier, and the animate tag within. Or you can use an ID and use the href link to the ID. So the animate tag needs to have a minimum of 4 things. The attribute name, which is the thing that you want to move around, the from value, the to value, and the duration. So I remember what I was saying that if you need slightly more control, you can use Simul, because you can set like click, and then it moves. Here we are moving x, which is the location from the 0 to the current position. It's like a translation thing, by 100 pixels, or 100 SVG units. There is also another form of using Simul, and that is with the animate transform tag. The addition is that you have to have a type of, say, translate or rotate or things like that. And this is the x and y values. Likewise, you can say click and it translates. Now, next, moving on to rotation. When you rotate, you have to use animate transform tag because you're going to transform it. No other methods otherwise. Likewise, when you click on it, it flies out of the window and comes back again. This is because it rotates around the top left corner. Now, we can fix it by setting the center of the origin right in the Simul element itself by setting, say, 100, 100, and it rotates properly. So this is slightly more confusing because you have to count the pixels in there as well. It's not so helpful if you're going to work on rotations. The way to write more than one animation in Simul is that you have to add new tags. And you can chain them together by using an ID on the previous animation and then say begin. So if I click on this, it will rotate and then start to change color. So this is how Simul animation goes. Next, let's move on to JavaScript. When you use JavaScript, you can use it for complex animations. Like the CSS thing that was shown just now, that was mostly JavaScript and some CSS. It supports all browsers, so you don't have to worry about it. And rotating SVGs, obviously, because it's a lot simpler. You'll see. The libraries that you can use to animate SVGs are GSAP and Snap SVG. There are also other libraries you can use, but we're going to use GSAP because animation is much simpler with GSAP, and it's a lot cleaner. So first of all, we're going to add the tween max thing in GSAP by using the below code. The GSAP syntax is like this: tweenmax.method elements, the duration, and your destination, how it will look like at the end of the animation. So let's say if you're doing translation, that means tweenmax 2, we're going to rotate 2. The attribute, which is specifically for SVGs, so we're going to translate the x from 50 to 100 right now, and we click on it, it goes like this. Rotation, likewise, if you put rotation 360 straight away, it will rotate around its own origin, which is slightly different from the other properties. But you can set transform origin to 50-50, and it will work flawlessly in all browsers. Now, if in the rare case you need to rotate around the SVG origin, you can say set 200, 200, which is the bottom right corner, and it'll flow out and come back in again. So this works in all browsers as well. Well, now we are done with the basics. I hope that wasn't too fast. So this one, we're going to make something more complex. So because my friend Jing here likes to play basketball, we're going to do a basketball animation. That goes like this. So if you notice, there is a translate X, which goes from left to right. There is a bounce animation, so translate Y. And then there's a rotating animation at the same time in this one. The SVG for the ball is pretty huge. There's 3 path elements. So we're going to copy it and put it into the code pen. Now, all right, there we have the ball. Can you see? Yeah, you see that. For CSS, when you're working with the ball animation, because we are going to use transforms all along, it's an easier way if we add more group classes so you have more elements to play with. So one way of doing it is like this. I'm going to do a quick one. And then we're going to close some text. I'm not going to worry about indentation right now. So now, for CSS, we're going to use animations because when you're using bounce, it's going to be hard to set the easing function. So in ball X, we're going to animate it from left to right. In ball Y, we're going to bounce it. And ball rotate, we're going to rotate it around its origin. So take note that because we're using transform origin 50/50, it doesn't work in Firefox. The keyframes for ball X and ball rotate is pretty straightforward. So you can paste it down here. Ball X just moves it to the left. Ball rotate just rotates it. So here, it rotates. Perfect. Now, the CSS for this one is slightly more complex. Like you have to count the different timings, and then you have to give the correct translation to it. And you have to set the timing functions to ease in and ease out properly. Otherwise, the ball doesn't bounce. So now if you run it, you have a look at this. Whoa. Oh, I think I had a typo error here. All right, doesn't seem to work properly.
There's a ball Y, and there's an A missing.
Oh, really?
Yeah. Scroll in the CSS a bit, Tom.
Oh, OK, thanks. So now if I click run, it drops. You can see the animation is slightly jerky in a way because it's hard to get the animations correct. Have a look at once again. It's kind of jerky because it's hard to calculate the timing functions and how it translates and stuff like that. Now, let's move on. Oh, this is the one I was supposed to show you anyway. Great. Now, as we go on to SMIL, we're going to rotate it the same way. So one is going to be X, one is going to be Y, and one is going to be rotate. Likewise, we're going to use 3 different groups. But instead of using classes, we have to use IDs because this is the only way to select stuff in Simul. So let me just switch over here and set this to class IDs. OK, great. So ball X would be animate transform, ball X, and you set it to, let me just remove all of this. OK, animate transform ball X from 0 to 600 for 2.5 seconds. So now it translates properly, so that's good. Now, for rotate, we're going to rotate it around its origin at 50/50. Likewise, it's 2.5 seconds. So like this. Take note that we have to use animate transform over here. And for ball Y, this is the killer part because you have to transform it and you have to translate it from up to down. The values you see here are like timing functions. The key times here is like timing functions that we have in the keyframes. So there's 14%, 28%, and so on. And the values here is a Y translate value and the X translate value. So you have to like bounce it up and down. Then you have to set the count mode to key spline, which stands for Bezier curves and stuff like that. Then you have to copy and paste the Bezier curve itself into the Simul. It's going to be a pain in the ass if you had to reuse this animation. So let's just copy it over and go into it. Now, refresh. Great, we have something like the CSS ball that we have. The calculations are exactly the same, so you see that it bounces a little bit jerkily as well, because we have to calculate the whole thing by ourselves. Next, with JavaScript. With JavaScript, it's a lot simpler because we don't have to worry about all the different transforms and translates. GSAP can handle it for us without a problem, so we can just use a class. So I'm just going to come back here and remove ball X and ball Y. And we're going to give a class of, what do I call it? Ball rotate, all right. And we're going to remove the animate transforms and the extra G tags. All right. So if we head back into the JavaScript, let me just copy this over first, and then we'll explain in here. OK. So in here, we're using two different timing functions. The first one will be an ease out. At the same time, it's going to translate it from left to right and rotate it. So if we run and click on this, it rotates and it translates properly. The second one, at the same time, we're going to do a bounce with an easing function. And now if I run it, and click on it, you see that it bounces. And you also notice that the easing is a lot easier to control because we can use easing libraries instead of trying to code one ourselves. So using GType is a lot simpler than using CSS animations or JavaScript animations when you have something of this kind. Now, let's move on to some cooler real-world effects. The ones that we're going to talk about are line drawing and shape morphing. So line drawing, you'll see something like this. It draws by itself. The method for doing this is that you have to use SVG with a stroke. If it doesn't have a stroke, this method doesn't work. So let's just remove everything else and just place the SVG in. Oh wait, I don't need this. OK. The first step of the line drawing thing is to divide the strokes into arrays, into small little pieces, by using the stroke-array property in CSS. Next, you have to offset the stroke slightly by using the stroke-def-offset method. The numbers here are calculations that these are just random numbers that you can use. So if you move over it, it really kind of looks cool, just that it doesn't have the full line by itself. Then you have to make the strokes longer so it covers the full path. So these numbers you have to go and try and calculate it by yourself. So this is kind of like the different way. So if we want to make it the correct way around, we have to set the stroke-offset first so it doesn't show up, and we animate it in on transform or on animations. All right? So for line drawing in summary, we're just going to set the dash array to the path length and the dash offset to the path length as well. The challenging part with this is getting the path length without and making sure that it works across all your browsers and all the devices, especially when responsive design comes into play. So this is usually easier with libraries. You can use your own JavaScript method to call the SVG path and get the total length of the path. Or you can use some libraries like Vivus.js, which can animate multiple paths for you directly without any problems. Or you can use something like a GSEP Draw SVG plugin or Segment, which is very new. It works exactly the same as GSEP SVG Draw plugin, with the exception that you have to pay for it. The good thing about this Draw SVG thing is that you can start your path anywhere and you can animate it however you like. So if you take a look here, I started the path from the middle and then I rolled it up. And that is not very doable with libraries like Vivus, unless you really hack your way through. All right, that's for line drawing. So we're going to go into shape morphing. For shape morphing, we're going to do this. Wow. This is what I got from Code Drops. So it's pretty cool. If you don't know Code Drops, please have a look. Your mind will be blown by the animations they have in there. So the trick to doing this boing boing thing is that you need to have a starting path and a path when you click on it. So like the ending path. The main thing here is that the path, the number of points in the path must match. What do I mean by that? So if you know some SVGs, you'll know that M stands for movito, which is the start of a path. And then if you take the number of lines here, C is one thing. Just look at the alphabets and you know how many points there are. There's S, and there's S. So there's like four points here. There's M, there's C, there's one S, and there's another S somewhere here. So there's 4 points in both methods. Then there are two ways to do this. You can use GSEP's Morph SVG plugin, which is paid once again. Or you can use Snap SVG. GSEP natively doesn't allow you to work with paths very well. Oh yeah, there's one more way to do this, and that's to use Simul. But when your path messes up, you'll be shit. So let's do how it works right now with the Morph SVG plugin. This is paid. So right now what we're doing here is that we have a start path, which is the circular one, and the end path, which is the oval one. And we're going to set visibility to hidden, so we don't see the oval one. Then, when we click on the button, we're going to set the start to the end. So the cool thing about Morph SVG is that you can set it to the ID of the path that you want it to morph into. So let me just remove this and you take a look. So if I do a run now, it will morph in there and stay right there without any problems. That's the coolest part about the Morph SVG plugin. Then now, if I want to bring it back, then we just have to set a delay, or if you use time, there's other methods, but this one is simple. We can just set a delay, and it bounces back after that. So something like this. Quite simple with Morph SVG. But of course, some of us are misers, like myself included. Oh wait, let me just talk about this first. Like, remember I was saying that one of the challenges with morphing shapes is that you have to have the same number of paths, the same number of points on the path. Well, the good thing about Morph SVG is that you can forget about that. And this is the only library where you can do so. Like circle to elephant, rhino to star, and back into an elephant and to a circle again. There's a lot of complex paths, especially with the rhino and the elephant, but it's simple when it comes to the circle and the star. Well, if you're working with SVG, if you're creating an SVG yourself, this is going to be a lot of work. But if you use Draw SVG, you don't have to worry about it, and it will animate for you automatically. So this is pretty cool. Anyway, if you don't want to pay money like me, so you can use Snap SVG, which is found on this link here. I have a link up there, so you can click on it if you want to. So in this case, we're going to do it slightly differently. We're just going to have a path that is the initial shape. So I'm just going to replace everything and remove everything here. All right, we have the circle once again. Then, just to make it simple, we're going to specify the start and end path in JavaScript. You can make it nicer by setting it on an attribute of the element if you want to. So we're going to initialize snap, and then select the path, which is kind of what it requires, then the start and end path. Next, when we click on the button for the first time, we have to make the oval shape. So this is done by using the animate method. The mina here is the async function provided by Snap SVG. Grammarly, oh my god. So the async function here is provided by mina. It's kind of like GSAP's async function I think it's not as powerful, but you can't use GSAP with Snap SVG just like this right now. So you can do that. Then once it's completed, we can pass on a next parameter, which is the onComplete function, and then we animate it back to the start path. So this is how we can do it. So I'm just going to copy it and replace it. Okay, cool. Now, if you take a look at this, once again, it goes boing again. So the thing about Snap SVG is that you might think that Snap SVG doesn't play very well with GSAP. That's kind of true. You can also call it, GSAP has this call thing that you can use to call Snap SVG animation methods, but it's going to go one way, so you can't do complex animations regarding that. So just be aware of it if you want to combine the two of them. Then, just a quick summary. For shape morphing, your paths must have the same number of points for the initial and ending path, unless you are using Morph SVG. And yeah, with that, I come to the end of the talk.
I noticed you used a lot of default timings, like ease in, out, and so on. Is that something you'd normally do, or would you usually customize them?
Well, I normally do use the default easing functions because I find that it's more important to select the right timing rather than the easing functions, because the easing functions out there are already pretty good. So the more important thing is to set the delays of the animation and the timings of the animation correct, rather than play around with the easing. Of course, if you are a pro with the easing stuff, feel free to play with it. I'm not that good with that personally.
Yeah, I saw that Chrome is actually deprecating the SMIL syntax.
Yep.
So would you suggest not using that at all?
Well, personally, I don't really like the SMIL syntax myself because you can't use it like across multiple elements. You have to copy and paste it. And it's going to be deprecated into Web Animations API, which I unfortunately haven't had a chance to look into yet. I would believe that I would forsake SMIL and use JavaScript or CSS animations instead as much as possible, and have a look at Web Animations API once it stabilizes, and take a look at how that goes.
I just want to ask about the performance on mobile phone. As I know, the mobile browser or web view or other method to run SVG will cause some serious frame dropping and other performance issue.
So are you worried about performance issue on the mobile?
It's an actual issue we have encountered. So I just wonder if you have some test or project used on mobile devices. Yeah.
Currently, no. I don't have like projects that where I use mobile animation straight away. But so far from my tests, it depends on how you use the animations yourself. So like if you use transforms and you don't repaint the browser as much as possible, it's not too much of a problem. Or you can use GSAP, which is amazing because it works very well and its performance is absolutely solid. So for me, I'll probably just play around with these two methods and see whether it works well or not. if it's really shitty, then I guess the animations might be a bit too much, or maybe try to cut down animations, because if you're using a mobile browser and you need to reach out to people at a high speed and they don't have good internet connection, then maybe that part is not so important after all. Or maybe it might be. It depends on what you're trying to do there.